Okay, so first thing, rewrite it so that you get rid of the roots and you have powers now. Okay. So the next thing is the argument, right? The inside part. Okay, so we're going to use that as your u. So we get 2x squared minus 1 as our u. Find du, so that's just the derivative of u. Okay. Next step we're going to do is solve for dx. So divide by 4x. So we get dx equals 1/4 x du. 1/3, 1/3. Yep. There you go. Okay. And okay. So we got our u, got our du, solved for dx. Now we got to plug everything back in. Okay. So the highlighted part right here is going to change to u. Everything else is going to, and then this part is going to change with this in here. Everything else is going to stay. So the x is going to stay. The power is going to stay. All right. So we have x times u to the negative 1/3 times, and then instead of dx, we got 1/4x du. Okay. We have x's and u's. Hopefully they cancel out. If they don't, we did something wrong. Or we chose the wrong u. That's usually the case. If that happens and nothing cancels out, I'd suggest going back to u. What was your u? Choose something else. Okay, but luckily this time they cancel out. The x's are going to cancel out there and there. So we have 1/4 u to the negative 1/3 du. Right? 1/4 I can deal with. 1/4 is just it's a multiplier. It's a coefficient. Okay, so I'm going to move that out to the front. Okay, so that's going to give me 1/4 integral of u to the negative 1/3 du. Now I can find the antiderivative using power rule. So it's going to be 1/4 times, okay, I'm adding 1 to the power. So when I add 1, I get 2/3. So I get u to the 2/3. And then I got to divide by the new power, which is 2/3. But instead of dividing, I'm going to multiply by the reciprocal, plus e. Okay. Multiply the coefficients, we get 3/8. Move u back in. 2x squared minus 1 to the 2/3 power, plus c. We're done. Okay. All right. So that was the problems we were kind of working on last time, right? And we worked on the problems that I was giving you are the ones that where polynomials like this, right? Polynomials like this, where it's algebraic. So this is kind of the same type of thing, right? That's kind of the same type of thing. And then we said, okay, so trig functions, right? We did a couple trig functions. We did a e to the x, right? We did the e to the x. We had a natural log in there. Okay. This is one that I want to try though. One that is a little different. So it mixes e's and so this is not on your sheet. So add this one to your sheet. Find the problems that we haven't done. We're not going to go back and do. We're going to just do 2 more and then we'll be done. Because the others that we left off were very similar to the ones we did before. Okay, so we're going to give you 2 more, and then I'll let you start on your assignment. Okay. because these two are a little different. They have ease and trig, which we've done before, but this one's a little different in terms of the layout. Okay. So U-substitution. So, oops, I forgot the most important part. That means we have to find the antiderivative. Okay. All right. So I have to find a U. Question is, which part of this is going to be U? Which part of this is going to be U? Actually, you know what? Let me change it too. Because that's squared. Let me rewrite the squared. Not necessary, but it's just a personal preference for me. Okay. Okay. So I have three options, really, because there's only three things. I have E, I have tangent of X, I have secant of X. One of those three could be U. Which one is the correct one? Which one do you think is the correct one? We're looking for the argument. No. Okay, so let's look at secant squared, right? Let's try secant squared. Let's see. So we're going to focus on this guy here, right? Okay, so let's make that U. Secant of X, right? So my next job is to do du, right? So let's do du. So what is the, how do I say this? What is the derivative of secant going to be? It's been a while since we've done it. Let's see. I believe it's secant tangent. Yeah, secant tangent. So the derivative is secant of X, tangent of X. Okay. Dx. Okay. Next step, solve for dx. So I'm going to divide by secant tangent. Okay. So this goes away. So I have dx equals du, and then 1 over secant of x tangent of x. Okay. Okay, so so my next step is plug everything back in. Okay, so when I plug in u and dx. So when I plug in u, that's going to be for here. So I'm going to have a u here, right? So let's rewrite this. I'm going to rewrite this. So I'm going to have a u here. And then instead of dx, I'm going to have this guy, right? Okay, so let me plug that in right there. Anything else I didn't write is still in there. So the first part, e to the power tangent x, that's still there. Oops, spread du. Okay. Okay, so we still have u's and x's, right? Down here. So our focus is down here. We still have u's and x's, right? That's okay as long as they cancel each other out. So will the x's cancel each other out? So will secant tangent of x cancel out with e to the tangent of x? Will that cancel out nice and neat? No, it won't. It won't, right? What happens is, because this tangent isn't a tangent, it's a power, right? It's not a base. If it was a base, it would cancel out with this tangent, right? And secant, I don't have a secant there, right? So it wouldn't cancel out. So what I'm going to do is I'm going to go back and see, maybe choose something else for you. Okay? This is good because this is when I see things happen, when I see students struggling, it's usually with this here. So mistakes are good. Okay. I don't want to make it seem like mistakes are bad. Mistakes are good because you see kind of, it's easy to make mistakes, but it's harder to see, to learn from them. And this is what happens when you have something that you, this is what happens when you, when we run into like kind of a brick wall. X's don't cancel out. I can't have X's and U's, right? Okay, so let's tackle the problem differently. Okay, so let's tackle the problem a little differently. So let me rewrite the problem here. So we have e to the tangent of x. What do we have? Secant of x squared. Was that the original problem, dx? Okay, let's try a different route. We tried secant of x as a u, didn't work out. Okay, we know it doesn't work. Now we have two other options. We have e and we have tangent of x. Go back to the very first page. So turn over your thing, go to the very first page. Is there anything on the very first page that kind of makes you think, oh, that could be it? Very top. This page right here. More importantly, the example one. This one kind of looks, the middle one, the second one, right? Yeah, the second one kind of looks similar to the one we did there, right? And we said the power was the argument. That's where the other part's hiding, right? We've seen a lot hide inside the parentheses. We've seen a lot hide inside the roots, right? We've seen some hide here. We haven't seen one that hide here. That's another spot that they like to hide. The argument likes to hide, okay? That's one way to tell. So let's go back to our problem and see what that is. That's tangent of x. What's another way that's kind of a key to me, kind of a bells go off in my head that says, hey, maybe that's going to be the correct u. Secant squared, right? And don't I have a secant squared in there? That'll cancel out nice and neat. That's another kind of bell in my head saying, hey, that's going to be it. Okay? That's the key there. Find something in there where its derivative is already in there and it'll cancel out nice and neat. Okay? That's kind of a way to do that. That's the way to look at these problems. So if you have a u, let's say u is tangent of x, right? Just like Sebastian just said, secant squared, right? Dx. Well, hey, I have one of those in there. And when I divide by it, it's going to cancel out this guy nice and neat. Okay? So let's divide by it. Okay. All right. So now we're ready to move everything back in. So let's go one by one because this one's kind of different. Instead of tangent, I'm not going to write tangent anymore. I'm going to write u. It's power. I'm not going to write the base yet. I'm just going to write u times dx. Instead of dx, I'm going to write this guy right here. Okay. Everything else stays. So what did I not take away? I didn't take away the e, and I didn't take away this part here. That part, those two parts are going to stay. Okay, so e goes here. Secant of x squared goes there. This part is going to come in here. So I got 1 over secant of x squared du. Secant squared of x's go away. All that's left is those. E to the u du. Now I still have e, right? But is e a variable? Is e a variable like x? No, it's actually a number, right? It's like pi, right? It's a number, right? So I don't worry about that. I can have e's and u's mixed up. Okay, it's not a variable. I just can't have multiple variables. U is a variable. E is not. Okay, so now I'm going to find the antiderivative. What's the antiderivative of e to a power?
E to the power plus c.
There you go. Yeah, it's the same as the derivative of e to a power. It's just e to the u and then plus c. Put u back in. U was tangent of x, and you are done. Okay. Again, yeah. Well, the derivative of u is just 1. Yeah, we would do that. Yeah, if there was like a 2u here, then I would need another. Then I would need more, right? But yeah, it's just u, kind of like just x. So the derivative would just be 1. So yeah, you don't need that part there. Okay. At the very, very beginning of day 1, when we started this on Wednesday, I told you the hardest part was going to be finding u. And we did a lot of problems where u was kind of obvious, right? U was kind of obvious. And you were maybe thinking to yourself, why did he say that it was going to be the hardest thing? This is why. This is why. The hardest thing about this is finding u. Finding something, not even calculating something. It's finding it. Okay? That's going to be the hardest thing. But once you kind of get in your head, it's okay to make mistakes. You just redo it. Okay, that's not going to be it. I'm going to try this guy. Then it's not that bad. Okay? You're going to make mistakes when you start do this on your own. When we finish this last problem here. Okay, one more problem. This is the same problem you had on the very front. The very, very front, that one that we looked at from the very front page. This is the last thing we're going to do. Okay, so let's talk this one through. Obviously 3 is not going to be u because 3 doesn't have a variable with it, right? So what is going to be u? And how do we know that's going to be u? So what's going to be u here? So if cosine of x is u, what's derivative of cosine? So if I put u if I make u, let's talk that through. So if I make this guy go here, what's going to go here? So let's try it. Let me put this in invisible ink so it'll go away. So if I make that there, what's going to go below it? What's going to go here? Negative Negative sign. Negative 1 times sine, right? Oops. Negative 1 times sine of x, or negative sign, right? Negative 1 I'm not worried about, because negative 1 is just a coefficient. But do I have a sign in there that will cancel out? Right there. That's how we know we made the right decision. That's how we know cosine is the way to go. That's how we know cosine is the way to go. Okay? So cosine of x, I put negative 1 times sine just to separate them, because I know sine is going to be canceled out here in a little bit, and negative 1 will just be a coefficient. Okay? So I'm going to divide by, oops, I forgot about my dx. Divide by negative 1 times sine of x. Negative 1 times sine of x. So I get dx equals 1 over negative 1 sine of x du. So du dx. Okay, plug it back in. So we have, I keep forgetting that. We have 3u times sine of x. Okay, now let me plug in my dx. I forgot that part too. 1 over negative 1 sine of x du. The sine of x's will cancel out. No more sine of x, no more x, right? That just leaves a negative 1. I just have a negative 1 here. Well, what I'm going to do is I'm going to multiply that negative 1 and put it in the front. Actually, in the front here. Okay, so negative 1, and then I have 3u du. Okay. All right, so how do I find the antiderivative of 3u? Well, if we don't remember off the top of our heads, what's one way to solve the problem? I don't expect you to memorize these, but if you don't memorize them, what should you do? Just say, oh, well, go to the next problem. What can I do? A couple of you have these. All right. Some of you have asked, can we use these on tests? Some of you don't even have this out right now. Why would I let you use it on a test if you don't even have it out? All right. So this is where we have it. We have, some of you guys have these out. Some of you, all of you have this, but this is the guy you should have out if you're doing antiderivatives, because this guy here that I don't recognize is right there. Number 4 on the basic formulas. Okay. A to the U. 3 is A. It even has the same letter. It has U instead of X. Okay. The one with this guy in the front, right? So if you don't have these memorized, I don't have these memorized. I don't have these memorized. I've taught this class for 5-6 years. I don't have these memorized. So I always have it handy, right? It's always handy so that if I need it, I have it right there, just like you should. Okay. So it says a to the u du equals 1 over the natural log of a. Okay. So 1 over the natural log of a. Well, a in this case is 3. And then it says a to the u again. Okay, so 3 to the u plus c. Okay. And then we have a negative 1 out in front, so it's just going to be a negative 1 or a negative. So all we got to do is plug in u. Plug the u back in. So we got a negative 1 over natural log of 3. And then plug in u again. U was cosine. We'll see. Done. Okay. So we've done a lot of different stuff. I try to give you different examples because that's the biggest complaint I've heard is, well, we didn't do one like that. We didn't do one like that. I've given you every single thing you're going to see. Now it's not going to be exactly the same, right? Everything's not exactly the same. So you might have to think on your feet, but you've seen stuff like this. And with U-substitution, it's easy to tell if you're doing it right or wrong. Because if you get to this point here and X's aren't canceling out, I did something wrong. Go back to the beginning. Okay. All right. Okay. So we have about 26 minutes. I'm going to give you some time to start on the assignment. So the assignment comes from your textbook. So what I did was I posted a PDF of the page in your textbook. So what I want you to do is it's on Google Classroom. So if you want to grab your Chromebook, you can. If you want to just use your phone, you can do that. It's totally up to you. I just want you to give you some time to start in class. So if you have questions, you can ask, and I will put the answer key right here. Okay. I can put the PDF up here. I just don't know if it'll be big enough to read.